In the previous video, we did a t-test, and we've got all of our information up here, and I figured out all the things that I needed to figure out to make it work. And we had left off saying, well, this was doing a t-test of 423,000 observations in each one of the data frames. What if we wanted to look at aggregate daily sales? So what we're going to do is we're going to do that test for aggregate daily sales, which means we're going to have to aggregate. So first of all, we've got our two data frames, DF34 and DF76. I'm just to have these be standalone scripts, I'm just gonna pop that down there. And now we're gonna create a couple of grouped variables. So this is grouped 34, and that's gonna equal DF34 dot group by, and we want to group by, in this particular case, sales date. And we're going to have grouped 76, and that's going to equal df76 dot group by, and here we're going to say sales date. Okay. So we've got our two group by. Now we're going to do an aggregation. Df summary 34 is equal grouped 34 sales dollars, and we're going to do an aggregation, and here we're going to again NP sum, and here DF summary 76 is going to be grouped 76 sales dollars, and again our aggregation is NP sum. All right, so now we've got our everything aggregated. Now let's put in our scipy dot stats dot mstats dot ttest independent, and we're going to look at this. The two, we're going to look at df summary 34 and df summary 76. And I guess we'll have to do this, we'll make sure we do this right. It should be sales dollars in each one. And each one, and we'll say again, equal variance equals true. Okay, so let's run all of this. Whoops, try that again. Run that cell. There we go. I have key error sales are. So I think I needed to. Let's take a look at what these DF summary 34 and 76 look like, right? So these are a series, sales dollars. I don't think I have to actually identify them as sales dollars. I think I could just leave that out. Let's see if that's true. All right, let's see. I think I got that all right. Let's make sure that these are working. Those are both working. And now let's just do this. Okay, beautiful. So now I got my new t-test. And notice, right? So we moved it from all that data, right? And now we're asking a different question. And the question is based on, are the sales per day different versus the mix of all the sales different? So it turns out that our conclusion is not different, right? It is, you know, our conclusion doesn't change. But the statistic is not off the charts like we had before. Before we had 1905 and, you know, a p-value of something to the negative 81st power. Here, the statistic is 3.63 with a p-value of 0.0003. So there's a point is a basically a 0.03% chance that these are not different. Still very small. Because the previous data frames had over 400,000 records each, there was a lot of power in the sample, right? Just lots and lots of power in the sample because there's so much data, right? But the question might have been, if we try to sell that as the sales are definitely bigger by a lot in this store versus the other, but if you looked at daily sales, that might not be the case because there's less power because you're only dealing with 361 observations. That's still a lot of data. Okay, so in this case, the size of the data was 361 for store 34 and 360 for store 76. Okay. Not as much power, but still enough to say our conclusions are the same. So while our conclusions did not change, the analyst, you the analyst, needs to think. You need to think about the question. You think about the question the decision maker is asking. What is important to the decision maker? Right? Got to start thinking a bit more business sense. Is it the average size of sales by brand by day, or just sales by day, or a question we haven't asked, sales by brand? Right? We've asked the question for these two stores, sales by day, but we haven't asked the question, sales by brand. Maybe that's interesting, maybe it's not.